Hello viewers, in today's session we are going to discuss yet another important and very conceptual problem from limits involving the greatest integer function, right? So here we have to evaluate this limit, that is limit x tends to 2 minus. Here the negative sign shows that we have to find the left hand limit of this function, which is e raised to a hundredth power of greatest integer of x plus 2 divided by 4, right? So here we'll evaluate this limit with the help of some important properties of greatest integer function, right? So let us call this limit as L, right? So here x approaches to 2 from the left of x is equal to 2, right? So here we have x is equal to 2 and we have to find the left hand limit. So when we approach x is equal to 2 from the left of x is equal to 2, we are in the neighborhood of x is equal to 2, and this point is 2 minus h, where h is a positive quantity and it is infinitesimally very small, right? And h is very small and it lies between 0 and 1, right? So what we will do here, we'll convert this limit in terms of h by substituting x is equal to 2 minus h, so that when x tends to 2, h tends to 0, right? So now this limit takes the form that is L limit h tends to 0, and remember here we have the greatest integer function two times, right? So here first we have the greatest integer of x plus 2, then we have the greatest integer of this entire term, right? And then we have the exponent 100. So here we have e raised to, then here we have the greatest integer function raised to 100, and then we have greatest integer of x plus 2. So x can be taken as 2 minus h. So here we have 2 minus h, then we have plus 2, and then here we have 4, right? Okay, so now we can write it limit h tends to 0 e raised to greatest integer. Here we have 100. This is 2 plus 2, 4. So we have greatest integer of 4 minus h divided by 4. So the first property is greatest integer of x plus m is equal to m plus greatest integer of x, where this m belongs to the set of integers, right? So m belongs to the set of integers, and here this x is a real number, right? So greatest integer of x plus m is m plus greatest integer of x for all x belonging to the set of real numbers. So now we can rewrite this term, that is greatest integer of 4 minus h, as greatest integer of 4 plus minus h, and we can take this 4 as m. So we can now write here 4 plus greatest integer of minus h, right? So now greatest integer of 4 minus h divided by 4 can be written as 4 plus greatest integer of minus h divided by 4, right? And now we can separate these two terms by writing 4 over 4 and 4 over greatest integer of minus h. So we have 1 plus greatest integer of minus h over 4, right? So now this limit L, it takes the form limit h tends to 0. We have e raised to greatest integer raised to 100, and for this term we can write 1 plus greatest integer of minus h divided by 4. So now we know that h, it lies between 0 and 1, right? So h lies between 0 and 1. So if we multiply throughout by minus 1, then we have 0 and the direction of the inequality get reversed. So here we have minus h, then here we have minus of 1, right? And we can also rewrite this inequality as minus 1, then here we have minus h, then we have 0, right? So when h lies between 0 and 1, then minus h lies between minus 1 and 0. So the greatest integer of minus h should be equal to minus 1. So we can now take greatest integer of minus h as minus 1. So now this limit L is equal to limit h tends to 0. We have e raised to greatest integer of 1, and then plus, here we have plus sign, then we have minus 1 over 4 raised to 100. So now we can remove this limit notation because here we do not have h. So now we can write simply e raised to greatest integer of 1 minus 1 over 4. So this is 4 minus 1 by 4, that is 3 over 4, right? So we have greatest integer of 3 over 4 raised to 100. And we know that the greatest integer of 3 over 4 is 0, because 3 over 4 is 0.7. This is 4 sevens are 28, then we have 5 here, right? So this is 0. So here we have e raised to 0 raised to 100, and this term is 0. So we have now e raised to 0, that is equal to 1, right? So the limit of this function is equal to 1 when x approaches to 2 from the left of x is equal to 2.